everyone, I'm Dishpane from 8C and today I'm back with new video, Metals and Non-Metals, class 10th. So let's start. Let's start with the differences between metals and non-metals. So now let's see the differences between metals and non-metals. So first of all, what are metals? Let's see. So metals are the elements which have valence electron on the last shell as 1 or 2 or 3, which means that in the last valence shell, how many electrons are present. This determines that the element is metal or a non-metal. So if you can't understand what's metal or non-metals, what are valence electrons and all this stuff, shell stuff, then you can see my video atomic structure in the description below. So first see that video and then hop on to this video. So are the elements which have valence electron 1, 2, 3 in the last shell. For example, let's take an element from the periodic table. It's let's say sodium. Let's just take sodium. So what's the atomic number of sodium? Tell me. Yes, it's 11. So let's make the atomic diagram. The nucleus and the 2 electrons of the first shell. And we know the capacity of the second shell is 8 electrons. So we'll make 8 electrons here. 3, 4, 5, 6, 7, 8. So the second shell 8 electrons and the last shell is 8 to 10, 1 electron. The valence electron in sodium is 1. So it is a metal. Now let's see in one more. Let's try one more. So now let's see if let's see yeah, now let's see if now let's see if calcium is a metal. So now atomic number of calcium is 20. So now let's make the atomic diagram. First shell 2 electrons, second shell 1, 2, 3, 4, 5, 6, 7, 8 electrons. The third shell again, it's 1, 2, 3, 4, 5, 6, 7, 8 electrons. 8 is 16 plus 2, 18. And in the last outermost valence shell, it has 2 electrons. So the last valence electrons are 2. So calcium is a metal. Now let's see about what are non-metals. So the elements which have valency of 4, 5, 6, 7 or 7 are non-metals, which they're not metals. So let's take an example of oxygen. The atomic number of oxygen is 8. Let's make the diagram. Sorry. Yeah. So 1, 2, and then again 1, 2, 3, 4, 5, and 6. 6 electrons in the last shell. So the valence electrons are 6. So oxygen is a non-metal. Now let's take another example of let's say carbon. So carbon atomic number is 6. Now let's make the atomic diagram. It's for, I hope you can see this, 1 and 2 in the first shell. In the second shell 1, 2, 3, 4, 4. So this is the diagram of carbon and has 4 electrons in its last shell or valence shell. So its valence is 4 and thus carbon is a non-metal. Now let's see some more examples and know more about metals and non-metals. Now we are on second point. The second point is physical appearance. So metals are generally solids. So most of the metals are generally solids. For example, gold, silver, etc. And there's some exceptions. Sorry. Exceptions, which are mercury. Mercury is a metal, but it's a liquid. It's a liquid state. And gallium. Gallium is a metal which is which is solid at room temperature, but when you take it to a hand, we put it on a hand or on human touch, the human body is around 36 degree Fahrenheit warm. So on this temperature of human body temperature, gallium melts. So on human touch, gallium becomes a liquid and mercury is a liquid. So these two are exceptions to the popular contrast that metals are generally solid, not non-metals. So non-metals are generally, you can take screenshots and notes for this. This is important. Are generally soft. Mean they're not hard like metals. They're generally soft. Soft, or we can say they are. First of all, if we talk about the physical appearance, like they're solid or state of matter, then we can say non-metals are of three types. Some of the non-metals are gases. 11 non-metals are gases. For some example is carbon, oxygen, nitrogen, ozone. So these are in liquids and liquid state, a liquid state non-metal, like liquid state metal was mercury. So in non-metal is bromine, liquid at room temperature, and solid, and rest all of them are solid. So this was the physical appearance of metals and non-metals. Let's hop on to next point. Now let's come to point number 3. So it's now appearance, how they look shiny or what. So it's a luscious. Luscious means shiny. So metal are luscious, like they have a, when polished, they create a reflecting surface, or in simple words, shine. So if in earlier times the scientists used to identify elements, like it's lustrous or it's shiny, then it's a metal, and if it's not, then it's a non-metal. So the exception to this thing, exception is lead or Tb has a dull appearance. Dull means like you wake up in the morning, dull, like always, that's what means dull. So lead has a dull appearance. Now with the non-metals are generally non-lustrous, means do not shine. And exceptions to this is diamond, because of its refractive index, it shines, and graphite, and even iodine, that purple liquid, shines. So these three nonmetals shine, rest most of them are generally non-lustrous. And metals, or most of the metals have shiny thing, are lustrous. Exception is lead because it has a dull appearance. Now let's hop on to point number 3. Here comes point number 4. So, point number 4 is metals are generally hard. Hard to feel, like the hard solids. So metals are generally hard. Exceptions are mercury, of course, it's a liquid, and it's sodium, potassium, and sodium and potassium. These are the exceptions: mercury, sodium, and potassium. And for the non-metals are generally soft. Exception: diamond. So this was point number 4. Let's hop on to point number 5. So point number 5 is that the metals have high melting and boiling point. So now metals have elements of metals, the atoms of metals have a very small, very strong metallic bond between them. So they don't leave them easily. They are holding each other tight. So that's what the reason why they don't melt and boil easily. Now exceptions are mercury. Mercury has a low melting and boiling point. That's why it's used in making thermometers. Now, and for nonmetals, is that the nonmetals have low melting and boiling point, which means that nonmetals can melt and boil easily. And the exceptions are, because chemistry is full of exceptions, rules don't follow so much here. So the exceptions are silicon. Silicon is a very good conductor, or very good, means it has a very high low melting and boiling point. It's exceptions to what is for the nonmetals. And this was silicon. Now this was point 4 and point 5. Now let's hop on to point 6. So point number 6 is metals are ductile. It means that they can be drawn into thin wires. It means when we apply force or we beat the metals, then they can form a thin wire. And a fun fact, that gold is very ductile. So if the gold can be is so ductile that 2 kilometer long line thin wire can be made from only 1 gram of gold. So this shows how much ductile gold is. And this is the example of gold and tungsten. These are very ductile. But exceptions are mercury. Of course, it's a liquid. sodium and potassium because they are very weak, so they can be cut with a knife also. That's another fun fact. And zinc. Now the zinc is another one. So zinc is very brittle kind of, so it breaks when you try to apply force, so it's not ductile. So this is an exception. What about non-metals? That they are not ductile, means they cannot be drawn into thin fibers like the metals. And the exception to this contrast is carbon. Long fibers of carbon can be made from only such less amount of carbon, so it's an exception. Now let's see. I hope you can see that carbon, C carbon. Yeah. Point number 7. Point number 7 is malleability. Sorry for the spelling. Malleability. So malleability means that metals, they can be beaten into thin sheets. For example, if in the early ductile, it was that we applied force in it, and they can become long wires, and it said that metals are also malleable, which means that if they beat them in certain manner, then they form many thin sheets. Like if you see aluminium foil, that is so thick. Aluminium foil is so thick. So we can, from metals, most of the metals, we can make thin sheets, which is called malleability. So we can say that most of the metals are generally malleable, and exceptions are, exceptions are always there. Exceptions are, sorry for the background noise. Yes, mercury, mercury, sodium, phosphorus, sodium, potassium, and zinc. These are exceptions. These 4 metals are not malleable. Are metals but not malleable. And for non-metals are not malleable. Yes. Non-metals are not malleable. And the exceptions, there are no exceptions, no exceptions. All the non-metals are not malleable. They cannot be drawn into thin sheets. Even carbon can also be not drawn into thin sheets. Now let's move to point number 8 and continue with this lesson. Point number 8 is good metals are good conductors of heat and electricity. Sorry for the disturbance. Good conductors of heat and electricity. And the exceptions are, most generally all the metals have, but the exceptions are the metals which are tungsten wire. So tungsten does not allow heat or electricity to pass through it. Now non-metals are bad conductors. Bad conductors of heat and electricity. And the exceptions are, so many exceptions, are carbon wires, carbon fibers, and graphite. So now let's hop on to point number 9. I hope you understood this. Good conductors of heat and electricity are metals. Exception, tungsten wire. Non-metals, bad conductors are heat and electricity. Exception, carbon fibers, and graphite, the lead used in pencil. Here is point number 9. So it means, now let's see first of all the valence electrons of metals were 1, 2 and 3, and of them were 4, 5, 6 and 7. These are for non-metals, these are for metals. Now as we know that every atom wants to fill its last row, its last shell, to make it to the maximum. So for example, like let's take a metal, let's take sodium. Okay, sodium is 11. So to here 1, 2, 3, 4, 5, 6, 7, 8. So 8 in this shell, and the last shell there is one atom, one electron, sorry. So this one electron, so now it has to complete its octet, or in the last shell it has to get the maximum electrons possible. So what's the maximum electrons possible is, sorry if I say too fast. So every atom wants in the last shell to have maximum number of electrons. Now what is the maximum number of electrons capacity of this shell? It is 8. So now it has 1. So it needs more 7 electrons more to complete this octet, complete this shell and reach an octet. The octet is when the last 8 elements in the last shell, and the desire, because every atom has a desire to reach the octet. So every atom tries to fulfill it either by gaining atoms or losing atoms. So now which will be easier for sodium to, no, it's this whole world is a game of pulling, tug and war, and wars all around. So now if this sodium element, let's name it Bruno. So Bruno is happening. Bruno has to snatch 7 elements. 7, sorry, not elements, 7 electrons. There are many sodium elements or many other atoms, and this Bruno has to snatch, take out the 7 electrons. 7 electrons, maybe from one or maybe from different, from many other shells. So what will be easier? Now he has to read in the last shell. It has 8 electrons, or the maximum capacity. So now which will be easier, to snatch 7 electrons or to give 1 electron? To snatch 7 electrons, it will use lots of energy, it will get tired, right? Bruno will get tired, so it will lose 1 electron, and then it will have a positive charge on it. Positive charge means a donor, a person, an element who gives its atom, its electron to reach the octet state is called an cation. Cation is called a donor, and donors have a sign, plus sign, and are also called cation. So all metals are called cation. Cation means all the metals are donors because they have 1, 2 or 3 elements, electrons in the last shell. So they tend to give away these things. They give 1, they give 2, and they give 3. So it's not easy to snatch, but it's easier to give when the electrons are a small amount. So metals have a plus sign. So when we say that write a metal, so we write a plus sign in front of it. It is called cation. So metals are donors. Now in the non-metals have 4, 5, 6, 7. So now it's easier to give a 4 or take 4. So 4 is both odd and odd, even and odd situation. So it can do both. Either take 4, combine with different 4, or do it. Let's leave this 4. Let's see 5, 6 and 7. So now it's easier for 5 to take 3 or give 5. It's easier to take 3. Why should it give its own property? It will snatch 3. So to reach 8, it will snatch 3. And element with 6, like it was oxygen we saw. So it's more easy for oxygen to snatch 2 electrons rather than giving 6 electrons. And same way with an element in an atom with 7 valence electrons, it will snatch 1 electron. Sorry for the disturbance. Snatch 1 electron and fill its octet. So when they take, so they are acceptors. So they are all anion. A-N-I-O-N. Anion. Metals are called cation, and non-metals are called anion. and they have a negative sign on them, which means the acceptors. They accept the electrons given by the metals. So they are donors and they are acceptors. So this is very important. So remember it, and you can also note it down in a notebook. Now let's see point number 10. Now let's come to point number 10. So, for example, have you seen elements like which are which have, for example, see this: CO2, O3, Cl2, O2. These kind of elements, like oxygen, we don't say. So these kind of elements are, in the nature, they are found in groups. So these are diatomic. They form bonds with to make them with their own kind of elements to complete the octet. So nonmetals are found like this in nature, like in diatomic. So if an element has two of its kind, like O2, the number is 2, then it's called diatomic. And if it's 3, then it's triatomic. Then 4, tetratomic. While metals exist only as single atoms like Na, K. So they are not K2, not Na2 or Na3. So if the metals are monatomic and non-metals are diatomic, triatomic, tetratomic, or we can say polyatomic. Now let's see point number 12 and the last point number 11 and the last point of the physical properties of elements. Now point number 11. Last one is how metals and nonmetals react when they react with oxygen. So when they form oxide. So if a metal oxide form, for example, NaO2, Na2O. So this when metals combine with oxygen, they form oxide. So always the nature of this oxide is basic. So the oxides of it's very important, and it comes in lots of CBSE and the competitive exams, that what is the nature of the oxide of metals. So the nature of metal oxide is always most generally basic. And now exception time. So the CrO3. So of chromium, when it forms reacts with oxygen makes oxide. So chromium oxide is acidic in nature. Just remember it, okay? And now the amphoteric, which means they are both behave like both acid. There is an oxide behave like both acid and base. So they are both acidic and basic. And these are aluminium oxide, zinc oxide, and lead oxide. Now let's hop over to nonmetals. So when nonmetals combine with oxygen, they form nonmetallic oxide. For example, NO2, SO2. So these nonmetallic oxides are all generally acidic in nature. But the exceptions to this is H2, HO2, CO. These are neutral, and some more. And these nonmetals are neutral. They are not acidic nor basic. So this was all in part 1, physical properties of elements. I hope you enjoyed. If I had some mistake, please point out in the comments, and share love and share this to your friends, and make sure to copy the link for me. Thank you.